Hello, everyone. My name is Andrei. I work with Compose at Google, and today I'm going to talk about Pausable composition. So it's kind of an advanced talk in the sense that I'm not sure how useful it's going to be in your day-to-day, but it's probably be really interesting for someone who really knows to learn about what we're working on, how we're improving Compose performance, and how Compose in general works. So Pausable composition. This is a new feature, performance feature, in a Compose runtime. And for me personally, it's like one of the most exciting performance features that we're getting to release in the next 1.10 release of Compose. So I'm going to talk about what it is, how we got there, how Pausable composition works in general, and what we're going to do with Pausable composition to improve your apps if you upgrade to a newer version of Compose, obviously. So to start, I want to talk a little bit about performance. When I'm thinking about performance, I usually put up this slide, which is 3 categories of how you want to improve, well, what do you do when you want to improve performance. The first thing I usually do is try to do less. So it's like trying to do some caching in between some operations. In terms of Compose, maybe do less recompositions, try to move the state reads out of the compositions, all of this like regular stuff about performance, that sort of thing. The second thing is do it faster. So let's say you have some operation take a long amount of time, and maybe you can optimize it by improving the algorithm or like changing the data structure that you use. Use a hash map there somewhere instead of like an array of, I don't know. So it's like usual CS stuff when you think about optimizations. You change an algo, it works faster, and square versus linear, and all of these things, right? And the last thing is do it some other time. So this is the scheduling tricks, where you don't really improve what you do during the actual operations, during actual code, but you try to schedule it in a way that makes the result available whenever you need it. And Pausable composition is firmly like in this third category. And this is like probably the first feature in the scheduling or like do it some other time category that we did in Runtime. But to get to Pausable composition, first we need to travel back in time, back to 2022. 2022 is roughly like Compose 1.3, 1.4, I don't remember exactly. And back then we get some bug reports about performance where it's just like, oh, this is the sample with some cards. We scroll it and it lags a little bit, and then it's fine. So what do you do about it? Like lazy list, scrolling a bit slow, what do you do the first thing? Well, you go to Perfetto. You open Perfetto, you look at this UI, you close Perfetto. But then you open it again, and you find like where your app is. I highlighted this in this blue thing. And you see something like this, which is slightly complicated. Let's go over what happens here. So the first line, the green thing with the number. The green thing is the frame number, I think. But it basically shows you how long the frame is expected to be. So device is saying, oh, you have like 16 or 8 milliseconds to finish the frame, and we expect it to start there, finish there. The second red thing is how long the frame actually took. In this case, we run out of time, and it's red because of that. And then everything below that is the slices that are recorded by the app itself. So we see there's like choreographer, doFrame. This is the framework calling back to Compose, asking it to render a frame. Then we measure and layout stuff, and during measuring layout, we do some composition. And composition takes a long time here. So these visuals are kind of complicated. I will simplify them a little bit for the slides. They will look like this. The same thing, we have the frame, we have the deadline as like this vertical line. It will be red or green, depending if it met the deadline. And then, again, we can see that composition in apply just does not fit into frame. We just took too much time to create, to run the composition for that particular item. So what do you do when your composition takes too much time? Well, you can optimize composition, of course, but also you can try to do it between frames. So this is the first optimization that we did in lazy layout. It's like been there in Compose for longest time. Restartable also does that, so that's where we copy it from. We basically try to do the next item in the direction of the scroll ahead of time. And this is called prefetch in lazy list, and it looks kind of like this. But the problem with that is even if you try to compose an item ahead of time, you can maybe let some frames draw incorrect amount of time. So basically you can see the first frame here, it met the deadline, everything's fine, but the second frame, it was delayed by this uninterruptible prefetch process. So what do we do with this now? So like we have composition, we need to do it at some point in time. We need to create the item or compose the item to show it on the screen. And the first thing when you try to do something not on a main thread, you try to multi-thread things, obviously. So this was the first experiment back in 2022. So instead of this, we try to do this. Now the main thread is free to render and do drawings and all those things. And meanwhile, in background, we try to prefetch the next item, try to make it ahead of time. It gives a smooth UI operation most of the time, but it does not block the main thread, which is important. But there are a few problems. So the first one is if we need to render this item on the next frame and we just didn't manage to prefetch it in time, well, that thread is still blocked. Like the main thread still needs to wait for the prefetch to be available there. So this is not great, but probably something we can live with. It's still better to start the work ahead of time, right? The second thing is multi-threading of effects. So as we compose on the background thread, we run into this problem that some part of the disposable effect here could be run in the background, some part could be run in main. And for example, here in this example, I tried to synchronize like some set of active screens in the view model with the screen that is current composable. And if we do it this way, where just like multiple threads running some parts of the effects, we need to make sure that this part is synchronized or like concurrent safe, so we support concurrent modification of the set. And this is not something we want people to do, to be honest, because, well, concurrency is complicated, or multi-threading is kind of complicated, and it's really hard to get right. And we will break a lot of existing people code if we do this thing. So this is kind of a showstopper. But there is also one more thing, is that if you run things on a background thread, system frequently schedules that on the slower core. So if you don't know the devices that we have in our pockets, they usually have big little architecture, which means that some of the cores are more powerful, some of them less powerful. In Pixels, you actually have like 9 cores in the new ones, whereas like one of them is the most powerful one, and this is what your UI is runs on, like most powerful core. But if the core is slower, it will run composition slower. And that means that technically like as we optimize for the time that it takes to execute the composition in some ways, we move composition on the background thread. It takes longer to execute, and we're actually waiting for it for a longer time on the main thread. So this is not great. But multi-threading is still kind of interesting idea. We will shelve it for now and try to do something else. Something else is called deferred content. And the idea here is to try to split composition in multiple parts. So we have this deferred primitive here, which is, if you see how composition works, there's like, how it runs, there's like a lambda that it accepts. And the expensive part would be basically scheduled separately. So we will get to this part, execute deferred composable, and then say, OK, everything else inside of it later. So instead of this, we do this. You can see here, so the composition runs in the first frame. It kind of does some part of the work. And then if you have some time in the second frame, we do the deferred composition and finish the item in there. There are some problems with that, though. So first of all, well, let's talk about good things first, though. So the composition now split over multiple frames, which is great. That's something we kind of want to do. Everything is on a single thread, so no longer we have synchronization issues between threads. Also good. It requires some changes in the compiler and runtime, which are kind of complex, but we can live with that. We did many complex things in the Compose runtime so far, so it's fine. These scheduling benefits can basically make the complexity justifiable. The issues with that are that this expensive part can be too expensive, because the only separation point that we have here is like this deferred thing. So like we can run the list item separately until the deferred part, and then expensive part separately. If the expensive part is too expensive, we get into situations where we still run out of time, because it's just uninterruptible function call. And when you call a function, you have to wait until it finishes, basically, if it's not a coroutine, obviously. But we're not talking about coroutines here. We're talking about composable functions. So a few more limitations with this approach is that people have to define their own boundaries. And maybe some people can optimize their app to define boundaries correctly. But if they are not defined well, then you get a lot of issues. And the deferred content is not interruptible in a sense. Like if we start running it, well, we need to finish running it. And that can delay the frame. So this is also interesting idea. There are some interesting ideas here, like splitting composition. But it doesn't work out well, and the complexity in the runtime and compile is not really justifiable for like marginal benefits that we're getting out of here. So we're probably going to shelve it for now as well. And what we're actually going to focus in these next 2 years is in the first two things in the pipeline, like of the approach and performance. We're actually going to do less, improve what composition does. We also improved modifiers quite significantly, and got like 30% scroll performance improvement out of all of the optimizations that we did between 1.3 and 1.9. And this is already great. We no longer drop that many frames that we used to. The performance is no longer that bad. But at some point, we start to run out of things to do. Like there is no longer so many low-hanging fruits where we just look at the trace and see, oh, this is so bad that we need to fix it. So everything now looks actually reasonable, performance-wise at least. So we go back to 2024, and this is where we start thinking about, okay, so let's come back to the same ideas that we tried with scheduling, and this time let's try to pause composition or split it in some other ways. So as we try to pause composition, we start to think about how it actually works and what can we do with it. So composition is usually separated, as you saw, in two phases, compose and apply. So what these two phases do. Compose is executing your composable function. So here I represented it as like this call stack, where like every function inside the composable is basically called synchronously. You have your row calling layout. Layout is calling the content inside the row. This is calling three texts. Each of the texts has like different composable scenario, like basic text, layout, and so on. And as each of those composables are executed, we build a change list. So we don't we don't do anything with the changes that these composables or the updates that is applied to the tree immediately. What we do is we build the list of changes that we need to apply later. This is done for various reasons. Most of them are mostly related to make sure that the composition is actually like a transactional property. In a sense, like if you do something in composition and it breaks in some way, we don't break the UI tree and other things. Like we handle side effects correctly and all of those things. In any case, so we put some of the things in the change list, we insert nodes, we update some data, we store some effects in there to be executed later. And after compose state finish, after we run the composable function that we wrote, we run the apply change, where we apply phase, where we go over the list of all of the things that we recorded, and we just execute them one by one. As they executed, we build the final UI tree that you see on the screen. We call all the callbacks in the effects, like disposable effects, launch effects are launched, all of these good things happen. And we also update the internal data storage to match the new representation of the tree. So if you think about composition, it's basically two phases. Compose, when you run composable functions, and apply, where you apply the changes that resulted from this composable function. And performance-wise, when you look at the traces from different apps and screens, it usually takes 70% of time to run composition and around 30% of that time to run apply changes. So if we focus on the composition, or like running composable somewhat more efficiently, we get a lot of gains out there, because if we try to basically go through this uninterruptible call stack and just slice it in half, or like some other ways, slice it in some ways, and just stop executing the function, we would probably be able to schedule it a bit better. But it's not easy to stop just executing the function. Like if you ever try to, you probably would just like interrupt the thread and just exit completely. And after you stop, it's even harder to start from the same time, from the same point where you stopped. But thankfully, composable functions are a bit special, and we can do something here. So we have this particular property in the composable functions that can leverage. If you try to compile a metrics in your app, you may have seen restartable skippable function. So what does it mean? Restartable property means that we can re-execute function more efficiently if we compose at least once, in the sense that we can find place in the composition where this function was executed before and just start update from there. It works in a way where we have this special lambda that we record, and it provides us with the way to call this function with the same parameters that it was before. Usually we use it for things like state updates. So if you have updated a state in the composable functions, notice that it's only updating the parts where this state was used. This is the restartable property. Skippable property of the composable functions allows us to skip executing function body if the parameters did not change. Well, technically it allows us to skip execution of the function body. We just use it if the parameters did not change right now. We use it, again, during updates mostly, where we figure out that, well, we no longer need to re-execute some part of the tree. We just can skip it, keep it the way it was before. We don't need to update it because the parameters are the same. They equal to previous execution. So looking at these restartable and skippable properties of the composable function, I just realized at some point that we can resume and pause using the restartable and skippable properties. So restartable property of a composable function allows us to re-execute, which is resume, technically. And skippable property allows us to not execute some function, which is technically pausing composition. Let's look at it a bit more in detail, how that works. So we start executing all of these pieces of code of the composable functions. We go through row layout, and let's say that somewhere here we run out of time. We need to pause composition and interrupt it in some ways. So we leverage this skippable property, and whenever we call into text, we just force runtime to skip every time. So it will call text function, but it will not call any of the code inside of the text function. It will just skip, and remember that those scopes, like this is the place where we did not complete composition. We'll continue further the next time. When we have more time, we can just continue executing these scopes. We restart these functions and continue executing them while we can. So let's say this time we execute the text and we run out of time again. Well, the problem is that we cannot pause the scopes that we restarted, so we have to still execute some part here. But we can pause or skip on the next part, which is the next restartable, skippable function, which is the basic text in this sense. And we continue executing like that, restarting from the basic text now, until we finish with the composition. So this way, with the restartable skippable properties, we can actually implement pausable behavior. We can pause composition and resume it later. The only change that is required in a compiler is like this small thing that is controlled by the flag before Kotlin 2.2 and is default for Kotlin 2.2, which released earlier this year. So if you compile your app with this version of the compiler, you get this behavior by default. If you use somewhat new version of the Compose, I would say 1.9, you also get it by default in the composables that are imported from Android X. All right, and this brings us to the feature that we have in the runtime that allows us to leverage this pausable property of the composition to pause composition. We call it pausable composition, and the idea here is that instead of doing this, we do something like this. We split the compose part of the composition, and we try to fit it between the frames in the lazy layout prefetch in the first place, but it can be used in other places as well. Let's look at some actual code and how it works in reality. So instead of doing regular set content, we're doing set pausable content now. Or more realistically, we're not using the runtime really. We're using compose UI, right? Like subcompose layout, all of those things. Well, there is in subcompose layout state, there's a create pausable pre-composition. And let's try to build like a simple feature with that, like prefetch some expensive content that we have in the subcompose layout. Basically execute it ahead of time, and whenever it's ready, we just present it to the user. Before that, we'll show some placeholder. It can be some loader or something that is really simple. Structurally, it doesn't take a long time to compose. So first thing we do is we extract the lambda out of the subcompose layout, which is generally is a good idea to do. But in this particular case, we need it because this lambda that we use in the subcompose, it should be the same instance that we use in the prefetch. This is handled by default by lazy layout for you, but if you build it manually, you need to make sure this like equality lambda matches in both places. So let's look at the post precomposition instance that you get a bit more. So by default, when you call set pausable content, the post precomposition that you get out of it is post, as it says from the name. And to drive the composition, you need to call resume with the should post callback. Basically, every time when compose will encounter the skippable point, it will ask this, check this callback if it should pause or not. And that's where you can control basically execution of all of the composables inside of this resume block. By the end of it, you get a Boolean back which says if there's anything else left to execute, true. If yes, false is false. And you can also query that with the isComplete property. After the composition is finished, after you run all the composable functions, we still have the change list to apply. So we have to call apply to finish composition and basically make it complete. But also at any time between the resume calls or before the apply, we can cancel precomposition and just dispose it, discard it. Because sometimes you scroll in one way, you prefetch items that's below, but you start scrolling the other way, you no longer need the items that's below. So we don't need to retain that memory. Yes. So let's try to build this feature. We are trying to prefetch an item, compose it somehow efficiently between frames. So the first thing that we do, we actually create this instance of the post precomposition. And then in the loop, we basically go over all of the frames, or all of the, in the loop, we just go and try to compose resume the composition, like run the composition in some ways until we are done with it. So in this case, I'm doing something a little bit stupid because it's the simplest way to do. I'm just skipping every time that we can. So whenever we encounter skipping or pausing points, I'm pausing the composition and then I'm going to be resuming it in the next iteration. And after I complete it, like current iteration of the composition, I'm just going to yield control to the scheduler, basically saying, if you have something to do on the main thread, please do that, and then we will continue prefetching the item. And then we're done with it, we just apply it. Or if we encounter cancellation from the coroutines, we just cancel the possible composition. And with that, we basically have our content pre-made for us, prefetched for us. And only when it's ready, we present it, measure it, and do something. So like if you look at the perfected trace of this feature, what you see is something like this. We're just like do many compose blocks in between frames, and at the end we apply. And you won't see like big composition block inside your measure or do frames anymore. So pausable composition, what it does, it allows us to split composition over multiple frames. It has these fine-grained pausing points that are embedded by the compiler for you. You don't have to do anything. It's just like kind of enabled by default if you upgrade to recent enough versions of the dependencies or Kotlin compiler. Limitation here, it only works with the initial composition, just in the way how API is structured. So we focus obviously on the creating the content, creating the items for lazy list or for subcompose layout from scratch. This is the worst case performance, worst case for performance for Compose right now, and this is where we actually need it most. But technically, with the pausable behavior, nothing prevents us to apply it to recomposition as well later. It's just something that has to be updated in a runtime. So what do we build with pausable composition? This is probably something that is most interesting for you if you care about performance. The first thing is more efficient lazy layout prefetch, starting from 1 to 10. You can enable this flag in composition, and it will give you the behavior I described earlier, where we split composition over multiple frames, and we already tested that in some apps, and they see pretty decent improvement for scrolling performance, which is amazing. In the near future, we're looking into building a beta component for you to prefetch arbitrary composable. So similar to the subcompose layout example that I described in the previous slides, but a bit more convoluted because prefetching is not that easy, unfortunately. It will just allow to do the same thing as we do for lazy layout, but for any kind of composable, and efficiently pre-make the screens or pre-make some kind of expensive content before showing it to the user. And the last interesting property of the last interesting thing that we can do with post-composition now is the fact that apply now is separate from the resume. So the executing composables and running effects are separated from each other in the API itself. So instead of running prefetch like this, where everything is in a main thread and we split, we just execute apply later, what we can do is actually do some multithreading and run composition on the background thread, and then apply on the main thread. This is something that's like really distant future. We're still looking if that's actually a good idea, because even in composables, you can do things that, well, will be really broken if you, not in a runtime, but like in actual user code. But it sounds like an interesting thing to explore, and maybe you'll hear something about it at some point. All right, that's it for me. If you have any questions about lazy layouts, performance, Pausable composition, or runtime compiler, you can find me around here. And thank you for your attention.